Hi, everyone. Good afternoon. Thanks for being here. I know this is the last session of the day, so thanks for your interest. I'm really excited to be here. OK. Today, we are going to be talking about how you can create and design serverless pipelines for analytics. So let me introduce myself. My name is Gabriel Ramirez. I am the CEO and founder of Bootcamp Institute. Bootcamp Institute is a company focused on training and certification on AWS cloud. I have 10 certifications ranging from professional to specialty, and I am the author of that book, the AWS Solutions Architect Associate Guide. And this year I was named AWS Community Hero for my work with the local communities in Mexico. OK? Well, this is the agenda. We will be discussing about some topics about serverless pipelines and why it is really important. Then we will move to anomaly detection, which is kind of the main topic. Then we will be discussing about Lambda architecture. It's not the AWS Lambda service. It's more like a design pattern. And we will discuss a business case based on a solution for AWS telematics for vehicle industries. And we will be checking on this solution architect with the Lambda patterns, right? OK. So why do we need data pipelines? There's a really important topic between ETL and real-time analytics. So data pipeline allows us to process data more quickly, more easy. And if you go to the serverless domain, this will make this will be easier with AWS services, right? So what's the data pipeline? Traditionally, you have to move data from one system to another. You have to process, you have to extract, you have to load, you have to compress, you have to normalize all this information to get insights. So that's the main topic about this streaming or these pipelines. It's about the latency that you have to answer some business questions. That's the real value of data. So this is all about speed, OK? When we are talking about real-time applications, maybe we are talking about latency sub-seconds. But if it's close to real-time, maybe it's 60 seconds or less. But if you go to the batch domain, maybe we are talking about hours, maybe even days, OK? So this is really important. We are trying to solve a very common problem in data processing. So if we move to the client-server architecture, we will see that clients are generating data, are interacting through APIs to HTTP protocols, and we have, on the other side, the server, OK? So if I talk about streaming, I mean that data is continuously generating. It's being created. So it's not like you have some requests. It's all the time it's gathering data. So if we would try to solve this problem with traditional architecture, we will need to take into account some topics. The first one is that the network is not reliable, right? Then, how about retrying exponential backup, client-side logic? That is important. Maybe I have some throttling issues. I need to scale that infrastructure. Maybe I can move to a virtualized environment. Maybe we can try another solution, and we can bring this to AWS. Yeah, we can use load balancing to accommodate more growth, to have more capacity. We can start thinking maybe on some kind of EC2 instances, maybe CloudWatch monitoring, maybe auto-scaling. That would be right to try to increase the capacity of the system. But at some point, this will reach a limit. And I also have a lot of responsibility from my side to be monitoring, to be scaling, to be adapting to those patterns. And remember that this data is continuously being generated. Maybe I can find some kind of database that can grow automatically. That would be right. This is the case of Aurora or maybe DynamoDB. Then we can re-architect this solution, and maybe we can start thinking about serverless architectures. Maybe an API gateway. This could be also an elastic load balancing. And the whole idea of serverless is to try to scale out horizontally. Yeah? So I don't have to be worried about provisioning, about scaling, about patching, monitoring, failover. All this is done really in a managed way by AWS Lambda, okay? But this also has a little problem. What happens if the network breaks? What happens if my Lambda function has an error? Yeah, that's not reliable. So to be reliable, I need some way to store this state, this knowledge, and to replicate this information. So in the case of an event or a failure, I can recover and start processing all this data. Yeah, this is important. So maybe I can put an SQSQ. I can use an API gateway. In fact, there's an integration with those services without any code. So that is adding a reliability capability to this solution. That can be really, really good. But I haven't really solved my problem because I still need to be aware of the correlation, the idea of sequence of the messages, the duplication logic maybe. Yeah, maybe I want to handle more protocols or more ways to interact with these solutions. There's some ideas that you have to take into account if you are designing a real-time streaming data pipeline or analytic solutions. The first one is automation. You don't want to do anything manually. You want to have the services, the infrastructure scalable that can react to data, that can recover automatically in the case of a failure. So you don't want to touch anything. You don't want to extract, load, and maybe analyze data. You have to think all this on the more managed way that you could have, yeah? So this is important because velocity is a high topic. So data is growing, it's coming, it's increasing in volume. So I don't have the time to start manually be provisioning and scaling resources. That's important. Also, most of these architectures are think to be cloud native. So they burn in the cloud and they stay in the cloud. I can think on CI/CDs. I can think about 12-factor design principles to solve these kind of problems. Maybe if we are a data-driven company, we can think of a data lake from the very beginning. And which services can I leverage to start ingesting and analyzing, performing machine learning, doing analytics, and discovering data, maybe patterns as data it's been generated. And I need to think about fully managed services that can help me to focus really on the problem or on the business and not on the infrastructure or the servers. And this is where Amazon Kinesis sits in. Amazon Kinesis, I think it's the best and the easiest way to ingest, load, and act for data that is continuously being generated in the cloud. It's the more straightforward services that AWS has. And it's a family of services. We have Kinesis Data Streams, we have Kinesis Data Firehose, we have Kinesis Data Analytics, and Kinesis Video Streams. So those are the 4 services that we have. What are the main use cases? Depends a lot of the industry, but maybe if we are talking about transportation, we want to optimize routing, we want to avoid colliding or accidents, we want to have some kind of logic at the edge, maybe. We want to make, I don't know, some marketing efforts based on the location of the vehicle. So there are a lot of opportunities to start building services around location, geo-reference data. Maybe for IT, it's really important if I have a deployment, if I have thousands of servers, to start thinking about observability and react on failed deployments to understand what's happening on my applications, why I'm getting a DDoS attack. So that could also be a good solution for Amazon Kinesis to start streaming all this log data and maybe even build recommendation engines based on the usage patterns of my customer base, right? Maybe I have some closed TV, surveillance systems. I can even use Amazon recognition to detect some kind of scenes or objects in the video. I can deploy machine learning on SageMaker with custom models, yeah, to try to understand some kind of interactions in the video. So this is very interesting. Maybe telematics. I want to send telemetry data from connected cars, from thermostats, for things that are connected to the cloud, and I want to react and make better decisions, okay? And Kinesis has this concept of throughput. Every record that I write to the stream is this channel on which all the data is being ingested, okay? It's been streamed. And we have several partition keys that we can use, and these records are added to every partition, to every shard into the stream, okay? And this has a fixed capacity, 1 meg per write, or 1,000 writes per for ingestion, and 2 megs per read, yeah? If I need to go ahead of these limits, I need to start to add in more shards. That's a way to do. Indeed, there's a good parent. If you are working on one shard, that shard could fail. Even because this information is being replicated in 3 availability zones at the same time, you need to think with more capacity. So maybe 2 shards is a good way to start, yeah? If you need to scale out, you can add more shards. If you want to scale in, you can remove the shards. There's an API just for that, okay? As you can see, every record has a payload, and this payload can be any message that can be codified, maybe base64, maybe binary strings, etc. And this represents the channel. This is the stream that I am using. Here's a trade-off in design. Maybe I can use several streams for several applications, or just one stream with several partition keys, and every partition, every shard is sending telemetry, maybe marketing, maybe, I don't know, some diagnostic codes from vehicles, yeah? So you can do this in a completely managed fashion. On the left side, we have several clients. So clients are writing continuously messages into the stream. And this is a very good way to decouple our architecture. So one big thing about serverless data pipelines is that you decouple the communication bus. So all the consumers, all the producers are completely decoupled because there's a messaging system in the middle, yeah? In this case is Amazon Kinesis. What advantages has this? I can change maybe the type of client, the type of producer that is sending messages, or I can change the implementation about the processing, the machine learning, the kind of solution. We have managed Kafka, we have SQS. I think it's not the best case, but it could be used also for decoupling this communication bus. And this is the main concept. On the other side, I have the consumers, and the consumer could be any kind of API. It could be an EC2 instance. You can implement maybe the client library, or even better, the Lambda functions. So each Lambda function is invoked every time a message arrives. And there are 2 kinds of APIs. The one, it's pooling, and the enhanced client is it's listening for the data that is being pushed through the channel. So this is great because this represents low cost, no administration, lots of flexibility, lots of scalability, and also it's a reliable solution for messaging, yeah? With Kinesis Firehose, I can analyze the data as is being captured or ingested and take some action. This corrective action could be, I don't know, some kind of optimization in the traffic. Could be, for example, avoiding an accident, maybe a thermostat that is going beyond the limit. So we can react very fast. This is important. The way that we analyze this data is through Windows. Windows it's a way in which we have to capture some based time data, yeah? And these windows can really leverage what's in the message for a fixed period of time, okay? Something really important about Kinesis Firehose is the flexibility. With Kinesis Analytics, I can use SQL. So this is like streaming ETL. As data is being continuously generated, I can be analyzing on these windows. I can perform machine learning algorithms. I can detect anomalies. I can detect, for example, hotspots. So there are some kind of embedded functions in this SQL, and this is really nice because I don't have to provision an EMR cluster. I don't have to start working with Apache Spark, which is a really good solution, but maybe it's not quite serverless. This is going to represent a cost. This is going to represent some management, monitoring, scaling, etc., right? Kinesis Firehose has the ability to receive the messages and store on S3, Redshift, Elasticsearch, or Splunk. So this is a completely a zero ops administration for Kinesis. So I can send this information. For example, I'm capturing all these logs, and then they go to Amazon Stream. I can replay those data, and in the big data context, I need to make an analysis of the 100% of the data, not just randomly. So I can really perform that kind of analysis. I need data warehouse capabilities. I can start using Redshift and maybe use, I don't know, some Snowflake structures to start to analyzing all these data. And Elasticsearch will give you really good capabilities to interact with the information, to query those information, okay, using really well-known products, yeah? Data analytics is going to be the tool that we can use to perform SQL. And Amazon has made a great effort on this area. So each product, each service that you use can be queried. This is the natural way of getting answers. So you don't have to learn a new framework. You don't have to learn a new language, new library. So only very SQL on top of the services, and that is good. You have a data lake. You can put a layer for SQL to integrate multiple data sources, and that's the idea behind a data lake, to remove the silos, to try to integrate all those data sources that are spread. And taking real-time decisions, that is good. We have several services. One of them could be Lambda, that could be SNS. Maybe we can listen to the stream of data that is being written to Amazon DynamoDB. So that stream could deploy or could active an event, and another Lambda function gets called. To analyze the IoT device data, there's a very good integration between the IoT services and Amazon Kinesis. So it's really straightforward to put this in practice. What is this about anomaly detection? This is a really interesting graphic. As you can see, data, as time passes by, data is losing their value. It doesn't mean that this data is not longer worthless, but as soon as I can get answers from those data, as soon as I can analyze, it will be of high value for the company, because we can react, we can take actions, yeah. Maybe I need to query the last 6 months or the last year of the company to understand some kind of patterns. That would be great, but the real-time decisions, maybe it's the ones that cost us less, okay? The more important. So this is really interesting, because the time-critical decisions happens in the real-time and seconds space, and we have minutes, hours, days, or even months to have batch or business intelligence. This is where a lot of product sits in, okay? But this is important because we have two sides of the data, okay? Which one is more important, the real time or the batch analytics? These windows can give us the possibility to start analyzing data. We have 3 kinds of windows on Amazon Kinesis Data Analytics. The first one is the tumbling window. This is a fixed window that starts reading discrete data, and when it ends, it starts another window, okay? So maybe this will be good for analyzing log data from the last 5 minutes. That could be great. And I can use a group by expression, yeah, maybe aware, and that could solve some kind of problems. Maybe the sliding windows is the most robust ones. Sliding windows can be observing data and start discovering new data as it's coming. Each new row that it's coming, it's going to be appended on this window, so that can be really more complete answers. And when we are talking about anomaly detection, really we are looking to find some kind of distribution that it's abnormal in data. So we will use random cut forests, we will use trees, we will start cutting this data until we find some patterns and try to identify which data it's the farthest, okay? And this data that is so far could represent something. I don't know, you are now in Vegas, and maybe if you try to make a transaction on your bank is going to block that transaction. Why? Because it's not normal. Because you usually make some transactions on your bank in your country with some range of IPs in maybe some states, but not in Nevada. So that's a good example, yeah? So we want to understand, and if we were to write an application that is if-then logic, it will be really complicated. It's not maintainable, it's not extensible. So these limits cannot be fixed. So we need to understand data in a different way. And it's just, there's a white paper on this, on random code forest. It's an algorithm, a scalable algorithm designed by AWS, as it's integrated with a lot of services. Recently, I have seen this algorithm in CloudWatch. So that's interesting. Without a machine learning model, without an endpoint, I can make inferences with new aggregated data for any kind of application. So this is really interesting, yeah? And it's an unsupervised algorithm. Okay, so the Lambda architecture. What is a Lambda architecture? It's a way in which we can model these two sides of the data, the batch one and the real-time one, and getting answers with the complete set of data. That's the past and also the present. So it's kind of complicated because when you try to analyze streams of data, you have to think on distributed systems. And distributed systems have in its nature to be eventually consistent. So that is complicated. How do you get answers of information which is not complete? That if you read, you can get a different set of results. So that's complicated, yeah? So what Lambda architecture tries to solve is to have a framework or a way, a design strategy in which two sides can be complementary, okay? Something really important about this architecture is that applications write to an immutable stream. This stream is not modified, it's appending only. It's all the time adding new data, so I can make queries to those information and go to the ETL layer also. Some kind of implementations on top of this, maybe it's a data lake, and also could be a MapReduce distributed with, I don't know, Lambda could be, or EMR. The Lambda architecture has these main components. We have the producer, which are the clients that are generating data, that are appending to this stream. We also have the batch layer, and this is where sits the EMR. This is where is Redshift. This is where is maybe, I don't know, a relational database could also find in this pattern. And also, we have the real-time layer. This is Kinesis. This is MQTT, this is, I don't know, maybe HTTP, this is the IoT service, okay? And at the final, we have this merge serving layer, which means that both layers have to be merged at some point to get valuable answers. Okay, so here the question is, what kind of technologies, what kind of services can I use to create that merge layer to have these answers in real time and also complemented with the batch view of the information. So that's a really interesting part. The business case that I want to talk about is the connected vehicle solution from AWS. So this is really the question we're trying to solve. How do we manage vehicles? How do we make automotives that are autonomous, that generate a lot of data? In average, each vehicle could generate up to 4 terabytes of information each hour. So this is really challenging to move this information, to migrate or push the data into the cloud. So how do we solve these kind of problems? This is a white paper about this solution. It's a CloudFormation template that you can try. And the connected vehicle solution is really like a framework to be extensible, a solution that can be adapted to many use cases. Use cases like voice, for example. There's a very good video on YouTube on a skill for Alexa for the connected vehicle solution. And they ask, hey, Alexa, where's my car? And they perform a geo-reference query, so you can know where is your car. Maybe you can ask Alexa, hey, Alexa, start the car. Or when you put on the key, maybe you generate a KMSK and you can start the vehicle, right? So this is really interesting. It's based 100% serverless, and it's based on IoT protocols and services. As this solution is serverless, it's really scalable. You can have, even with the IoT simulator, 1,000 vehicles to be simulated to see how this works. It's really nice. And also is based on analytics. It uses the Kinesis data analytics and other services to try to answer some questions about anomaly detection, about trip, about driver score. And this is the solution architecture of the connected vehicle. As you can see, we have IoT things connected to IoT core. IoT core here is acting like a message broker, okay? Takes all this information and automatically it starts moving to managed services. In this case, it's for Kinesis. Indeed, this is a part of the ingestion. And so this is the central point of communication, and it is really secure because it uses TLS mutual authentication and X50 certificates. The IoT core is the service that allows to communicate with things. So to communicate these things with the cloud, we need a managed service like the IoT core. It's scalable because it uses a publisher-subscriber model. It can handle trillions of messages per second, and it's designed to be really reliable. Yeah, it uses MQTT and HTTP. So this is good because MQTT is a protocol designed to be used where communication could fail. Also, the IoT service is designed to manage all these connected and disconnected things via device shadows, so you can save a state of the object, and when it gets reconnected, it synchronizes with the latest information, so this is fine. And it's extensible. We have the Greengrass core service, and this Greengrass service could help us to perform analytics and compute on the edge. So speaking again of connected vehicles, it's complicated to move all this data through unreliable connections, so you have to execute models. You have to inference locally on the device where the data is being generated. So this is really important. What does Greengrass is that has a model of communication local for each device. So if you are running the Greengrass core, you have this group definition. And this group definition is like a logical managed group of things, which can include connectors to talk to third-party services, of devices, okay? Maybe this is the hardware part. Lambda functions, so this is good because Lambda functions get pushed into the devices onto this substrate and can run the IoT core service. So the same programming model of Lambda can be pushed down to the connected things, in this case, the vehicles, right? If the vehicle is disconnected, it can talk with another vehicles and try to make a good decision to try to avoid maybe an accident or try to optimize a route. When they get connected again, they can synchronize with the cloud. So this is really, really interesting, okay? And has some components like a root certificate, some settings. So this is like the way you can abstract all those things and that can communicate. It also has a subscription table, and this defines the logic and the ways that Lambda functions can communicate with each other and with the connectors. Let's talk about the speed layer. This solution for connected vehicle, it's handling all the information that it's been generated by those vehicles via the IoT core. The IoT core has this concept of topics, and these topics can be customized to move information from one service to another without coding. So these topics will put information, data, as blobs in S3, so that gives us a possibility to replay all the events that have occurred, or maybe do a prior investigation, yeah? If you have an audit, maybe it would be good to have a durable place to have all these data. So this is interesting. Also, it communicates with the Kinesis Firehose. The Kinesis Firehose uses some applications like the Kinesis Analytics, and Analytics is performing the random cut forest to try to detect anomalies. So these anomalies give us a score, and this score can be fine-tuned depending on your use case. So it can be as sensitive as you want. Maybe we are talking in the industry, 3 standard deviations could be a good metric for detecting an anomaly, but that can be defined in your applications, okay? So every time an anomaly is detected, that is put into another stream, a Lambda function gets called, and this Lambda function is persisting this anomaly in a designated table in DynamoDB, okay? Now, I have speak about this solution, but how does the Lambda architecture fits with the connected vehicle solution? So maybe this is the architecture. So I have the producer layer. Here I have IoT things. Here I have IoT greengrass. Also can use some kind of simulation with the Kinesis data generator. I will make a demo in just a moment. And the IoT simulator tool. It's really cool. It's a way in which you can model device things and put them on the registry with all the characteristics that these things have. If it's a thermostat, if it's a vehicle, if it's, I don't know, so some kind of custom hardware, right? And the speed layer, it's again, the IoT core with all the topics. These solutions have 7 microservices. And as you can see, one of those topics, the telematics one, it's pushing all this data into a Kinesis Firehose data stream. That stream, it's analyzing in tumbling windows all this information, trying to detect anomalies, but also trying to aggregate information that is good for business, for marketing. This information, again, it's in the anomaly, it's persisting in the DynamoDB table, and you have several other functions like, for example, the driver score. So each time you finish a trip, it's calculated the driver score, trying to predict or trying to understand how fast you were driving, how hard have you braked, and this score is compared with other users. So that can make really useful information for companies where they trying to understand if this customer is really risky, or maybe, I don't know, for an insurance company. So that is really good for answering questions. This also has some diagnostic trouble codes and location-based marketing. Also, there's a function to the notification service trying to publish to an SNS topic every time an anomaly is found, every time a trip is end, or every time trouble code arises, okay? And then we go to the batch layer. Here's where things are processed more slowly, but you can complement these kind of questions. There's a really good feature that was recently announced for Amazon Athena, and it's a federated query. Federated query allows customers to query on different data sources, on heterogeneous data sources. So you can query database tables for Aurora, for RDS, MySQL, Postgres. You can query maybe objects based on Athena with the Metastore. You can also query DynamoDB tables, so you can make a join with these 2 data sources. You can also query CloudWatch logs, for example. So this is really integrated into many services. So this is the way that we can merge those layers and get these final answers, checking on all the previous past data, and also checking on the current windows that are generating data. So that kind of answers are of great value for companies and for customers, because this can complement this framework to really understand what's happening and to look at the past and give more comprehensive questions, okay? I have a small demo of this. The first one is really simple, and it's creating a delivery stream. So let's see how this works. This is a Kinesis data generator. For those who haven't used this tool, it's a CloudFormation template. It creates a console. Indeed, it's creating a user on Amazon Cognito, and this user lets you authenticate, as you can see. You can create that stream, In this data stream, I'm putting a name. You just need the name to connect to it. And then it asks how many shards do you want. For this simple example, I really use one shard, but you in production must be using more than one. Okay. And now it's ready. It's ready to start ingesting data. So this sensor stream is going to be receiving all the information generated by this Kinesis data generator. And it uses some kind of templates to model data. You can put event-based data. You can put some kind of randomly distributed data via weighted arrays. I'm choosing here the region. Now I can find this stream. That's easy, really. And as you can see, I'm choosing this template. It's a JavaScript library called faker.js. And it's going to randomly start generating data and the volume that I want. In this case, is 100 per second. Yeah. And as you can see, it's reporting. It's a sensor, temperature. Yeah. It has the device ID. And it starts sampling data. And it starts pushing this data into the stream. I really used 300 messages per second, so I can get more quickly this demo. And here in the monitoring section, I can see that messages are being arrived. So one important thing about Kinesis is you can see how fast is this solution. Even when I'm working with Kinesis Data Firehose. Data Firehose represents some kind of latency. If I want to be real-time sub-second latency, I have to work with the Kinesis data streams. That's the API directly. So I need to use the put record API. I have to create the client and the consumer, and this is the fastest way to get answers. But Kinesis Firehose is completely managed, so maybe we can sacrifice some seconds to have this infrastructure all run. In Firehose, Amazon implements the client, so you don't have to. As you can see, messages are arriving into this stream, this one single shard. And let's connect an data analytics application so we can perform SQL on this data. It's asking for the name and then where the origin of this data. We have a Kinesis stream already, so let's connect it. You need to specify a role. This delivery stream will put this data onto a stream or maybe Elasticsearch or Splunk or Redshift. In this case, I want to make it durable, so the destination is an S3 bucket where I can have the whole bunch of data so I can analyze it every time. And this is the batch layer, right? Not the speed one. This is the batch because it's taking the information and it's persisting every bunch of data. Okay, now we're finished. We have this delivery stream pointing to an S3 bucket. As you can see, you can ask also for compression. And Kinesis Firehose can also do the encryption, so this is really good. It's server-side encryption. If you were working with Kinesis data streams, you can perform the encryption on the client side. So before the data is being pushed, you can encrypt this information. You can aggregate, you can compress, and if the data is compressed, you can optimize the throughput of the network. You need to specify a role. I have a role already, so that's the last step in this configuration. And at some point, we will start seeing this information arriving in the S3 bucket. It's that simple, okay? Now, with this information in an S3 bucket, I can create a Athena query, yeah? All those information is being referenced in the Athena data store. It works like a Hive metastore. So if I have a compression algorithm for this data, I can start making queries, I can start making joins, and with the federated get query, I can start aggregating information from other data sources. For example, DynamoDB, to check the trouble codes from DynamoDB and check the location-based marketing or the trip data that I have in this S3 bucket that could be used. There's a search in the data, so this has been generating. And in just a moment, the S3 bucket will appear, and we can check what kind of data is being generated. This can be done also with the CLI. That is really straightforward, but I think this tool is really helpful to try to simulate something and start working and see how this information is arriving and how could you process further, okay? So there it is, there's information. Something important is that it's partitioned by time. So data on S3 must be partitioned. So I have the year key, I have the month, I have the day, I have the hour, so that, because all streaming data is time series data, so the time component is really important. And then I open this file and I can see all this information from the sensors is right there. So, okay, we have solved the batch layer, no problems. Okay, so now let's move to the anomaly section. For this demo, I have used the IoT simulator console, which is really nice, really good experience. And I have one car running of two. You can put up to 1,000 cars at the same time. Then I start another car, and as you can see, there's the telemetry data that is being generated. So you can subscribe to this pops-up topic of the IoT service and start seeing how this data is being generated. So this simulator won't generate anomalies, so I will do that manually. And the anomaly, the SQL application is looking for the oil temperature. So if this oil temperature is really high, it will perform this anomaly. But I can do that also with the geofencing, with latitude and longitude, with speed maybe, or maybe with the OBD information from the car. So this is a really straightforward example. I have here the source. I will go to analytics. I will start this application. And this query, at the last part, if you can see, it's watching the oil temperature and checking on this score that the RFC algorithm is performing. In this case, this is the sensitivity. It's, let me check. We have our right there. I think it's 30. Now I'm filtering this column, and as you can see, as data is coming through this application, it's showing here. This is the dashboard when I can see all the things connected and how they are performing, what bandwidth. This is the MQTT client. I will subscribe to this topic, so is telemetry, connected car telemetry, and the VIN, the vehicle identification number, and I will put some anomalous data. I will report a temperature of 500, I think, and that will show really quickly right there. As you can see, all the values are negative, but this is really, really high. That value that we are seeing is the score, yeah? And this score is reported here in the DynamoDB table. So there is the whole application, the DynamoDB stream, the Kinesis Firehose, the SQL application reporting to another stream, that stream invoked a Lambda function, and that Lambda function right to the DynamoDB and reported to the NSNS topic. So you could also get a notification on that anomaly that is being present. It's really quickly, okay? And again, what happens if I want to start observing anomalies but on trajectories? Maybe we have trucks, we have taxis, and we want to understand if those vehicles are inside a geofence. So this could be really interesting. I'm using two libraries here to visualize this data. So as you can see, there's a geofence on the right side. Our vehicles coming and going out, and it's reporting in real time. Where are they? And on the other side, I have some points of interest, and I try to seek if the vehicle is really near of that point of interest, or it's getting outside those boundaries. Maybe I could use some location-based marketing for that use case, and in the other, to understand how vehicles are getting in and getting out, so a company can optimize the delivery based on that. In fact, the right example, it's a use case for example, Amazon. What happened if that Amazon truck is passing nearby and you can go and pick those things? You could get a notification on your mobile phone, yeah, and maybe you say, hey, yeah, I want to pick up on that location because it's near from where I am and don't have to wait until it's near your home, yeah? Okay. Well, this is the small demo that I have prepared. So I think we can move with the questions. Does anyone have any question about this? Okay, yeah.
So the question is, at least in my experience, in most cases, you cannot do any kind of stream analytics without enriching just telemetry data with metadata.
Mm-hmm.
Right? Type of vehicle, you want to measure the oil temperature, and so forth. So how do you see and where that kind of data enrichment should happen in your model?
Excellent question. How can we enrich those streams with metadata, right? In the Firehose, you can add some data. You can enrich those data, and that is common. For example, if you have a vehicle with the ID and, I don't know, latitude and longitude, but you want to complement this data with, I don't know, some behavior of your customers, you could put this data and start analyzing in those windows for real time, or maybe batch. It depends. But yes.
Where would you kind of do that data merge?
The data merge happens on the SQL application on data analytics for Firehose. That would be the best place to do that. You could also do it with Lambda, but on the SQL join could be the best scenario. Yep.
So you can actually join common data, stream data with something like dynamic tables?
Yeah, inside the stream. That would be the fastest latency. Yeah. Yeah. Another question? Yeah, over there. You can go to the mic, please. Thanks.
Not a problem. In the case of a connected device where there's connectivity gaps and not wanting to implement greengrass per se, is there any recommendations on how you would handle the backlog of data once connectivity is restored?
Yeah, I think the best way to handle that is through machine learning models running locally, and that's the advantage of the greengrass core, that you can execute some kind of logic, maybe slow down, yeah?
But then, so for those past the immediacy layer, the batch layer, I suppose, where for business purposes you need to know, say for a connected car, if they're going above the speed limit when there was a connectivity gap, if we need to get that data at some point,
yeah.
Should it just be, say, collecting it in a queue and sending it through the IoT core through MQTT whenever it gets connected, or say, collecting it in a log and then uploading it that way?
Well, it depends. Maybe there must be a synchronization process where this connectivity is established. So it's very common to have slow consumers. So that's the case. When the vehicle gets disconnected and it joins the stream again, it's a slow consumer and starts pushing and synchronizing this data, but you have to act locally and then try to solve maybe with some kind of cloud logic to understand what is needed to be done.
Okay.
Yeah. Okay. Well, one more question. Okay. Well, thank you very much and hope to see you soon. So have a good day.